Hi guys, welcome to today's recording. We are going to go through the NCEA Level 1 Mechanics exam that was examined in 2020. So as always, if you've been finding my channel useful, please leave a like of the video and then subscribe if you haven't. I think about 80% of my viewers aren't subscribed to the channel, so if you could, if that's one of you, and if you could change that, that would be fantastic. Okay, so let's go through some mechanics today. So being a marker myself for genetics and acids and bases, I personally think mechanics is by far the easiest external standards in NCEA Level 1. The amount of writing you do in comparison is much less, and as you can see on my screen right now, you have the equations given at the top of the on the resource sheet. So all of these equations are given to you, so you don't need to memorize any of them. You just need to know when to use which one, what unit does it have, and then just make sure you don't screw up your calculation on your calculator, then you'll be fine. Okay, so let's hopefully, if you weren't so confident, but then saying that, a lot of my students aren't confident with mechanics. I don't believe it's a science aspect. I think it's a the mathematics abilities that's letting them down, because most of the time you need to rearrange equations, which you're only looking at 3 factors, which shouldn't be too hard, but well, some of my year 11s will tell you different things. But let's get started. Right, so question one is what type of graph is this? This is a speed time graph. So first thing first, when you see speed time graph, just look on the axis. This is speed, this is time. So they even told you this is speed versus time graph. How nice of them. So let's have a look at some of the clues. So Felix, the famous jump from height, 40 kilometers above the earth. He fell for 240 seconds or 4 minutes before opening his chute. So it's a graph for the first 60 seconds of his jump. Describe his motion in section A and section C. So this is a speed time graph. So whenever you have a speed time graph that looks like that, kind of like that, you can see for section A, well, let's just get rid of this. This doesn't help. They kind of labeled everything already. So section A is looking at from the beginning to there. So this is a straight line. So when you have a straight line for a speed time graph, this is showing acceleration. Okay, you can say constant acceleration. That's fine as well, because the speed is increasing. As you can see, as time goes by, speed is increasing. So that's acceleration. Section C, this is a flat line, and for speed time graph, this is constant speed. Okay, so just make sure you know which one you're looking at. Like, so I'll draw it again. Like, say for something like this. So it's exactly the same graph. If this is speed time, this is distance time, they mean 2 different things. Okay, so for like say A, B, C, for a speed time graph, this is acceleration, this is constant speed, and for C is constant deceleration. All right, and for a speed time graph, A is constant speed, constant speed, B is stationary, and C is constant speed but going in the opposite direction. Okay, so as you can see, the shape of the graph are completely the same things, but you need to look at the axes labels. All right, moving on. State the maximum speed reached by Felix. So maximum speed is right here, 350 meters per second. So a lot of it, like, it's not even hard. You just look at the graph and everything's on there. Use a graph to calculate Felix's acceleration in the first 30 seconds. And then look, they even told you the answer. They said, all right, what is the acceleration, what is the motion for A? And look, they even told you, oh look, first 30 seconds is acceleration. So they can't make it any more easier. All right, they're giving you clues all around the paper. So we're trying to calculate acceleration. So in this case, we're calculating the gradient. So we're just calculating the gradient. All right, gradient is rise over run. Rise over run. All right, so how we do this, let me just go back to the graph. Now with the graph, this is how again, to help those that aren't so good at math, I tell my guys to look at the points. For section 8, this is my initial point, this is my end point. and I simply ask them to go, all right, look at this, put your finger on this point, put your finger on this one, and ask yourself, how high did it go up by? So you went up by this high, which is 300. How much to the right did it go? Which is, what is essentially asking yourself, what is the vertical distance? What's the horizontal distance? Okay, so it went by 300 up and went 30 to the right. So that's going to be 300 divided by 30, which is going to be 10 meters per second. All right, so acceleration unit must be ms-2. Use a graph to calculate how far if he fell in the first 30 seconds. All right, so the distance, let's go back here, calculates how far he fell. So we're looking at distance. When you're looking at the distance, calculating distance for a speed time graph, you're looking at the area under the graph. Okay, so let's find this thing again. So again, the first 30 seconds. So this is where, if I use a different color, so this is, if the first 30 seconds, you can see this is a triangle. This is a triangle. So you're just trying to find the area of the triangle. Triangle is half times base times height. What is a base? How long is this line? That's 30. How high is this line? That's 300. It's all on the scale. You can just look it up. So it's going to be 0.5. Scroll down. Where's my pin? So that's going to be half times base times height, which is half times 30 times 300, which is going to be 4,500 meters. Okay. Now, so same graph again. Now, next section, we are going to draw a labeled force diagram on the diagram below to show the size of the direction of the vertical forces on the person in section A and section C. All right. So again, so for section A, we know section A is acceleration. We know section C is constant speed. Okay, so we established from the previous question. So if I look at the person in section A versus the same person in section C, the downward force, so you can imagine the person is free falling. If something is accelerating, that means the force of gravity is going to be, actually let's draw this on the person. The force of gravity, or the weight force, is going to be greater than the force of resistance, or air resistance, or friction, or whatever you want to call it. But if it's a constant speed, the force of gravity or the resistance force are the same. But for this one, the force of gravity is bigger than the force of resistance. Okay, so why is that? Because this is what we call the net force. All right, this is what we call the net force. So I know that's going to come up, so that's why I looked at it here. Explain in the motion in A and C, comparing the vertical forces. So we are looking at the net force. When net force is 0, that means you're either going at constant speed or you're stationary. All right, so you're not moving. Like, say for example, one of the really popular TV show at this time of the year is the Squid Game. So if you haven't watched that, give it a go. It's a very nice show. But one of the games they played is tug of war. All right, so you ever play tug of war? So if you're trying to pull two teams pulling the rope, so if the two squads on each side are the same strength, then the rope wouldn't move. All right, because the forces cancel each other out, because the force equals 0. But when the net force isn't equal to 0, so that means one side is stronger, then that's going to cause the object to accelerate in the direction of the net force, of the side that has more force. Okay, so this is something that's really, really important. So if you look at section A we know is, we just wrote just now, the gravity force is greater than the reaction force or the resistance force, or whatever you want to call it in this particular case. So the net force is not 0, therefore it's going to accelerate. And in the section C, we know that the gravity force must be equal to the reactive force, because the person is going at a constant speed. If you're going at a constant speed, the net force is 0, so they cancel each other out. So you just, there's no external, there's no extra forces, so you just go at a constant speed. Okay, so that's why parachuting questions are quite popular. So here we go. So the net force is a key thing they need to understand, and the best example is the tug of war. Like, so if you're pulling by, like say for example, if you're pulling 10 newtons this way, someone's pulling by 5 newtons that way, that means the net force is going to be 5 newtons to the left. So you will accelerate to the left. Okay. So here you go. Section A, the gravity is larger, therefore they accelerate. All right. In section C, the force balances that, so net force equals 0. Therefore, no acceleration. Therefore, you go to constant speed. Okay. Very simple concept, but you just need to watch out for the application of these concepts. Okay. Next one. Each year, firefighters run up the Sky Tower. I do that for fundraising. Each day she climbs a height of 25 meters below starter for 2 of these days. Compare the work done. Okay, so work, if you look at the equation at the top, work equals force times distance, and power equals work divided by time. So these equations are all given to you, but you need to know what they stand for. All right. In your answer, you should calculate the work done on each day. Okay, so let's do this. So day 1. All right, so what do we know? So work equals force times distance. All right, so what is this force? So what Lindley is trying to do, she's trying to climb stairs. Yeah, so she, in order to do work, she has to get her own body weight above 25 meters above ground level. So in this case, this force in this particular example is the weight force. Okay, this is the weight force, because there's no reason why they will give you the mass in kgs. So for regardless of day 1 or day 2, her force is always going to be mass times gravity. Gravity is just 10. It's going to be 80 kg times 10 newtons per kilogram. That's going to be 800 newtons. So this is going to be the force that we'll be using for all of these equations, okay, because that's her weight. That's how much force she needs to do, that's how much force that she needs to do work in order to get her body mass up 25 meters. Now, so we know that. Now, so let's calculate the work done. So the work, well, actually it's the same. Day 1 and day 2, the work is the same, because it's the same person, 80 kilograms. She climbed the same height, 25 meters. So what do? Work equals force times distance, which is 800 times 25, which is going to be 20,000 joules. All right, unit of work is joules because it's energy. Yeah. So the work is the same. Calculate the power. So on day 1, her power is going to be work divided by time. So how many seconds did she do? She spent 50 seconds to climb 25 meters. That's impressive. All right, so that's going to be 20,000 divided by 50, which is going to be 400 watts. On day 2, she also did 20,000 joules of energy, but she did it in 30 seconds, which is going to be 670 watts. Okay, W is the unit for power. So calculate the work done, compare the work done. So the work done is the same. Okay, so they do the same amount of work. Why is that? Because it's the same mass, well, same weight force, same weight, and same height. On day 2, she spent more power because of less time. I'll use an example where everyone understands, yeah, because of less power, because of less time spent. Let's say, for example, if you can imagine year 11 science class, yeah, if we were to find out who's the strongest person in the class, and we just go, all right, we'll just do press-ups, and we'll just go, all right, like say student A do 10 press-ups, and we'll time how long it takes you to do it. For student number 2, who has exactly the same mass, happen to have the same mass, all right, we go, all right, you do 10 press-ups as well, and we'll time time you how long it takes you to do it. So as you can imagine, if the mass is the same, so what do they do when they do press up? They push their own weight. Yeah, if the weight is the same, so the work they do is the same because they both do 10 press-ups. Okay, so they do the same job, they do the same amount of work, but what differentiates the difference of the two is the amount of time it takes for them to do it. The stronger person should be able to do press-ups quicker, hence he's more powerful because that person did the same amount of work under less time. That means that person is more powerful. Same in this scenario, when you have the same person climbing the same height, but the only difference is the amount of time it takes her to do it. Obviously, the less time it requires, the more power you would have put into this particular work to get it done quicker. Okay, so that's this part. Part 2, Lily looks at her helmet falls off. The helmet falls between the zero without touching them. She estimates the helmet would hit the ground at 20 meters per second. Using conservation energy, assuming no external forces, calculate the height from which the helmet fell. The helmet is 1.5 kilograms. So just really quick, so what it means by the assuming energy or conservation, like say for example, if you pick up a pen or pencil and if you hold it up like say 1 meter, and then if you drop it, it's going to make a sound. Yeah. So if you by holding the pen to a particular height, your pen has gained a certain amount of gravitational potential energy, and when you let go, that gravitational potential energy, it will be transformed into kinetic energy. Now, not all of the EP will be converted to EK because as you can imagine, as the pen travels, it's going to occur, be slowed down by some friction, and then when it lands on the floor, it's going to make a sound. So not all of the energy. So in reality, when you drop something, like in this case a helmet, your EP is going to convert to EK, maybe some sound, maybe some heat. This is the real scenario. All right, but conservation of energy means in an ideal world, like say, if we just ignore all of these, ignore everything else, all of the EP is converted to EK. So EP equals EK. Okay, but this never happens. All right, because we just ignore everything else. We just say there's too insignificant, EP equals EK. Okay, so this is what they say. So just understand, so when they say assuming energy conservation, that just means EP equals EK. And what do we know? How can we calculate one of them? We know speed. See, this is the thing. When I do these questions, I just look at the unit. EK equals half mv squared. So I know the mass, which is 1.5 kilograms. I know the speed, which is 20. Don't forget to square that. I know that my EK is going to be 300 joules. If my EK equals 300 joules, my EP is going to equal to 300 joules. And how do I calculate EP? EP equals mgh, which is going to be 1.5 times 10 times the height, because I don't know what the height is. 1.5 is the mass of the helmet, 10 is gravity, and EP equals 300, because EP equals EK. Therefore, H will equal to 20 meters. Okay, by just solving that. Okay, so this is a very, very important concept. Very popular question, gets asked every single year. Just make sure you understand this part. All right. Explain why helmets would not reach a speed of 20 meters per second. So this is what I meant. This is saying that, all right, in theory, all of my EP is converted to EK. In reality, this doesn't happen. All right, because some of the EP will go to most of the EP will go to EK, but then you get some sound, you get some heat, and therefore not all of the energy from the gravitational potential energy is transformed into EK. So you're not going to reach 20 meters per second. Okay, so because air resistance happens, some of the energy will be transferred to heat and obviously to sound. As it lands, it will not reach 20 meters per second. Okay, very, very popular question. Make sure you get on top of that. All right, and then for question 3, define mass and weight. So I have it right here. Mass is the amount of matter in an object. Weight is the amount of gravity acting on the object. So one thing that you can think of it, mass is how much matter that makes up you. Okay, don't just go, oh, mass is kilograms and weight is newtons. I've seen answers like that so many times. That's not right. You don't give me the unit to define something. Like, you don't tell me, oh, what does height mean? You don't just go, oh, it's meters. That makes no sense. All right, so if I were to ask you what is height measured in, then you can tell me meters. But if I ask you the definition of height, you say how tall something is, all right? How far away it is from the ground it is, you know, something like that. So mass is the amount of matter that make up an object. If you weigh 65 kilograms, you will have a mass of 65 kilograms on Earth. You have a mass of 65 kilograms on Mars. Your mass doesn't change because that's the amount of atoms and cells that's inside you. That will not change. But what changes is weight, because as you go on to different planet, they have different gravity. When you have different gravity, you will have different weight. Okay, so you know, when someone technically asks you how much do you weigh, you should answer in newtons, because weight is about, you know, the amount of force that we're looking at. All right. Next one, explain what 10 kg -1 means. So it's just in here, as you can see. They said that gravity on Mars is 3.7 newtons per kilogram. Earth is 10 newtons per kilogram. 10 newtons per kilogram, it just means for every 1 kilogram of something. So this is, let's write it in English. This is 10 newtons per kilogram. So it just means 1 kg, there's 10 newtons of force. That's what this particular thing means, okay? So for every 1 kilograms of mass, there's a weight of 10 newtons, okay? So if you weigh 60 kilograms, you have 600 newtons of weight force, okay? Next one, calculate the weight force. So weight force is the easiest one. F equals mg. So if you know the mass, all right, if you know the mass, you just go 2,500 times 10. This is 2,500 times 3.7, because the mass on the gravity on Mars is a little bit different. So this is going to be 25,000 newtons. This is going to be 9,250 newtons. So you know, it's the same vehicle. All right, so it's the same vehicle, but then if you put the same vehicle on different planet, you weigh less on Mars because the gravity is less. Okay, now there are 6 wheels on this vehicle with a surface area of 0. Look, they start highlighting now. So 6 wheels, 0.25 meters per wheel. Calculate the total amount of pressure. So pressure equals force divided by area. So calculate the total amount of the thing. Now we need to use some of the clues that we calculated before, and this is one of the tips I need to give you guys with mechanics. Especially in the individual large question, like say question 1, question 2, question 3, the numbers that sometimes you're like, where is this clue? I don't get given it. It's probably in the answers that you've done in the previous answer, and this is a really good example of that happening right now. So pressure equals force divided by area. So we know the force is right here. On Earth is 25,000 newtons. Wait, are we talking Mars or Earth? Earth, yeah. So on Earth, so we need to know the force is 25,000. The area, each wheel is 0.25, and there's 6 of them. So just do that, and that's going to give you 16667 Pascal. Or if your teacher taught you newtons per meter cubed, this is also fine, but Pascal is by far the easiest. All right, and the Mars vehicle is placed on similar soils on Earth and Mars. Explain why Mars sink to different depths on why the vehicles sink to different depths. You'll support your answer with the calculation. So we just did that right just now with the Earth one. We can do the same calculation on Mars. Okay, so if this is on Mars, the force we did it just now is 9,250. That's the weight calculation, divided by 6 times 0.25, and that's going to give you 6166 Pascal. So as you can see, on Earth, the pressure is small compared to the pressure on Mars. Why is that? Because if you look at the calculation, so on Earth, the weight is bigger. The weight of the car is larger. Yeah, and then they have the same area, which is 6 times 0.25. It's those same 6 wheels. Okay, so if you have larger force distributed over the same area, then that will be ending up in more pressure. Okay, so you have larger weight force or less weight force on mass, area is the same, the pressure is less. So this is talking about the opposite. Like say, if I give an example, if a person who weighs 80 kilograms, ends up step on your foot, compared to a person with 60 kilograms wearing the same type of shoes, assume the shoe size is the same, step on your foot, obviously the 80 kilograms person is going to hurt you a little bit more. Okay, because it's the same amount of area, but then the weight force is greater, and that's going to be distributed over that same amount of area, and then you're going to feel that, and that's going to be a bit of pain. Okay, so this is it. I personally feel this is a very easy exam compared to some of the older ones. And like I said, look at the amount of writing that you're required to do. Not that much. I think this is the standard. This achievement standard. This particular exam can be achieved in I'll say less than 40 minutes if you know what you're doing. And be aware that these equations are given to you. Learn to use them, especially if you're someone that want to do physics later on in year 12, year 13. This is just so fundamental. And yeah, all the best, because I know the mathematic components some of you might struggle with. Okay, so hopefully that helps. Leave a like if you found it useful, and I'll see you guys next time. Bye bye.